In this video, we're performing differentiation using the quotient rule. In this example, we're going to differentiate the function y equals e to the x over x squared plus 4. The first step is to identify the components u and v. So we have two functions in the fraction. The top of the fraction is e to the x, and the bottom of the fraction is x squared plus 4. So looking at the formula, the top of the fraction has to be u, so u is e to the x, and the denominator is v, so the v has to be x squared plus 4. So now we've identified u and v, we have to differentiate both of these. The derivative du by dx is e to the x because the exponential function is its own derivative, and then we get the derivative of v is dv dx, which is equal to 2x. Then finally we can put these into the formula for the quotient rule. So dy by dx is equal to du dx times v minus u dv dx, all over v squared. So notice that the formula isn't symmetrical this time, so we have to be careful with the choice of u and v. This gives us dy by dx is equal to du dx, which is e to the x, multiplied by v, which is x squared plus 4, minus u, which is e to the x, times dv dx, which is 2x, all over v squared. Remember that v is x squared plus 4, so dy by dx is e to the x times x squared plus 4 minus e to the x times 2x, all over x squared plus 4 squared.